Okay, so good day everyone. Okay, today we will going to discuss about your chapter 2 lesson 2, which is your regions under the normal curve. Okay, so previously we have already introduced to you the concept of normal curve and its properties. So now we will going to start exploring what is inside your normal curve. So for example, we have here from the previous lesson, we showed on how we were able to know or to get the area of a certain z values given that it's in the area from the mean. Okay, so for example, we have here z is equal to 1.25. Okay, so we have the illustration here which shows that the area covers of 1.25 from the mean is given by this shaded portion. Okay, so we express the area from the mean as z such that it is between 0 and 1.25. That's how you express the probability. What do we mean by that? This only means that there are c values which is included in this range which the area is located. So for example, what are the c values that is included there? That is 0.51, 0.1, 75. So those c values has what we called or contain the area which is from mean to your 1.25. So after that, if we want to know the area from the mean to 1.25, what we are going to do is simply look at your z table. Okay, so locate it in your z table. So we have 1.25, of course. First, express z is equals to 1.25. Express it in three forms. Okay, the first one, z equals 1.2 for your, of course, for your vertical values of z, the vertical values. Okay, and then next, hundredths. The hundredths part, we have for the hundredths, replace 1.2 to 0 and then copy 5. So if you're going to add that, that's still 1.25. 1.2 plus 0.05, that's 1.2. So that we could locate that based on our z value. So here is your 0.005 and your 1.2. So next is find the intersection. Of course, the intersection for that is given by your, okay, here 0.39435. Okay, so let's go back. So we have that already. Okay, we know already that 0.39. Let's check if we do that here. Okay, so we have that here. That's your 0.39435. That's the area. And of course, if you want to show it in your illustration, just put it here. This is 0.39435. Okay, but it does not necessary anymore as long as you put it in your equation or your formula. Okay, so as simple as that, just locate it on the z table. Okay, next, but now that is not always the case that your shaded portion or the area is always this way. So how about if the area is far from your mean. How would you able to know that? Okay, this time I'm going to show you how to use the minus and the plus sign in that matter. How about next? For your minus, make sure that you know the location of your z values, the given z values. Okay, because again, we will going to use two properties. The previous properties that we have discussed, the first one is the area is equal to 1. And the second property is your normal curve is symmetrical, which makes it the area to the left of the mean is 0.5, and the area, we will going to express that by the area to the left of the mean. Okay, the area that is given by the area z, which is located at the left side of the mean, which is less than 0. Okay, this is one of the property, always take note of that. That is 0.5 or 0.50 or 50%. And also this is based from our symmetrical and your area, which is equal to 1. Z, the values located to the right of the mean or to the right of 0, the area for that is 0.50. This 2 is always a given already based on the property. So here we have, here for example, okay, so let's have some examples finding the area under the normal curve. Okay, so when z is equal to negative 1.5, determine the area to the left of negative z, to the left of z is equal to negative 1.5. Okay, how do we able to know that? Okay, first, the most essential way and the most easiest way is, of course, you draw your normal curve. Draw your normal curve. I need some very nice normal curve. Okay, so here is your 0. Next, we're going to divide it. Okay, 0, 1, 2, 3, and then of course to the left of 0, that's negative 1, negative 2, and of course negative 3. Okay, so negative 1 point given. Our given is that z is equal to negative 1.50 or negative 1.5. Of course, again, when it comes to area, the area to the left and the area to the right are equal. So that means we can use or we can still utilize the same normal curve. Okay, regardless if your z is negative or positive. Okay, so first, of course, the given is z is equal to negative 1.50, but we will going to determine the area to the left. Okay, so here is your 1.5 between negative 1. This is your negative 1.5 or negative 1.50. Okay, illustrate. And then we need to determine the area to the left. This is the left part of your negative 1.5. So as you can see, in this case, we cannot say that we could only use the area which is negative 1.5, because again, negative 1.5 talks about the area from the mean going to this area. This is the area of negative 1.5, not this area. Okay, so In this case, what we are going to do is simply minus. Okay? What do you mean by that? Okay, utilize the whole area to the left. We know already that the whole area to the left, this one, is 0.5. Okay? Area to the left of Z, the whole area. This whole area here going to the left is 0.1, including the shaded portion. Okay, so since that is already given, we need to also to eliminate the area of negative 1.5 to determine the area to the left of negative 1.5. Okay, so we're going to base it on your illustration. Okay, that's why illustration, when it comes to determining to the left and to the right of a certain z value, for example, this is, we know already that A and B are also z values or z scores. Okay, so in this case, first we need to know what is the area that covers this part, the negative 1.5. Okay, so we will going to get the area of this part from your, of course, from your z table. Okay, so your z table indicates that the area of z between, which is your negative 1.5, between your negative 1.5 and z and 0, okay, is equal to, we'll locate that one first. 1.5, this is 1.5, of course, again express it in 3-digit form, the 1.5 and the 0, 0, 0. Okay, so your 1.5 is here, this is your 1.5 and your 0, 0. Okay, so the area for that is 0.43319. Okay, this is the area, this is 0.43319. Okay, next, but what we need is the area to the left. Okay, again, utilize your property. So that only means what we're going to do is simply use both formula. That means we will going to minus, of course, to determine the area to the left. Okay, so P, or probability of Z, which is to the left, that is 0.5. Okay, and then probability of Z, which is greater than 1.5 but less than 0, that is 0. From our here, 0.43319, and again we said we will going to minus, so bigger value or greater value minus lesser value. Okay, minus P negative 1.5 Z. Okay, that is, this is equal to 0.50 minus 0.43319, and the area for that is 0.186660. Okay, let's check. 18660. Okay, that's the area that's the area that covers this part. This is 0.06681. Okay. Okay, let's check that one. Okay, sorry. Okay, let's check that one. Okay. Okay, so this indicates, by the way, this indicates the area of Z to the left of negative 1.5. Okay, so that's given by, let's check if we got it correct. Okay, so as you can see, this one is equal to this one. Okay, okay, we're done with this one. Okay, so we're going to next. Okay, this part, and then add. Okay, next, how about we have letter B. I think we have letter B for this part. Okay, how about if determining the area to the left of 1.75. Okay, so determining the area to the left of 1.75. So as you can see, here is the process for that one. And then to the left of Z is 1.75. So our given here already is Z is equals to 1.75. And note that 1.75 is located to the right of your Z, of your normal curve. Okay, so but we're looking for the area to the left of 1.75. Okay, to the left. This time, is it to the left or to the right? Okay, let's check this one. To the left. Okay, to the left of 1.75. Okay, so still normal curve 0, 1, 2, 3. Here 1, 2, 3, negative 1, negative 2, negative 3. Here 1, 2, 3. Okay, up, and then locate 1.75. So 1.75 is somewhere between 1 and 2, near 2. So, and as what we have here, description, that's to the left of 1.75. Take note that as you can see, it covers also the left part of your normal curve. And going back to your property, the left part of your normal curve, which is Z, which is, Z is below the mean. Okay, so that is 0.50. So as you can see in your illustration, this part is covers the what we call left of 1.75. So next, that's the mean. The mean here, we're going to color the mean another type of color. So we have here the mean. Okay, and then another type of your part is this one. Okay, so simply because it is between the mean and your 1.75, we could say that the expression for that is Z is between 0 and 1.75. Okay, if that's the case, of course, go back to your normal curve, since it covers the area between the mean between the mean and 1.75. Okay, so we will going to have, here is your 1.75. So in that case, here is your 1.75. 1.7, of course, 1.7 and 0.05. Okay, so intersection, so we have that intersection, we have 0.45994. Okay, 0.45994. Okay, so look at your illustration. Your illustration states that your area is more than 50%. Okay, your area is more than 50%. In that case, remember, if it's more than 50%, what you're going to do is simply add. Okay, if it is more than 50%. So in that case, we will going to add these two equation. That means it is P of Z less than 0 plus P of Z between 0 and 1.75. Okay, so next we have, okay, copy the formula, P of Z less than 0, because that is the area that indicates to the left of the mean, plus P of Z between 0 and 1.75. Okay, that is 0.5 for the area to the left of the mean, plus 0.45994. Okay, so that's a total of 0.95994. That is the area of your shaded portion. Okay, this is a total of this part lang. Okay, it is a total of, right, we're going to write something, so that's 0.95994. Okay, that's the area. Okay, so another thing to remember is the between. Okay, if that's the case, we have here already the third one. Okay, for the between given Z is equal to negative 1.5 and Z is equal to 1.75. Okay, so in this case, for example, so we will going to utilize the Z table. So the P of area of Z between mean, okay, erase. Z is between negative 1.50 to 1.75. Okay, that is given by, first, P of negative 1.50 plus Z between 0, that is we will going to indicate first the given. Okay, illustration. For the illustration, we're going to look for between. So, create your z-table, your normal curve, I mean. Your normal curve, okay, here. Okay, 0, -1, -2, -3. Then 1, 2, 3. Okay. Okay, and then 1.75, 1.75, and then 1.5, -1.5, and then 1.75. And then as you can see, between, right? So between, this is your between already. Between. Okay. So as you can see, it covers the area of your 1.75 and the area of your -1.75 to the mean, and your area of 1.75 to the mean. So in that case, so that means we will going to utilize your z between 1.5 negative and the mean that is given by 0.43319. It's given by your 0.3319. Okay, 0.33. Is that correct? Negative 1.5, 433. Okay. 43319, and B, okay, between 0, 1.75, that is 0. Okay, 1.75, 0.45994. Okay, so in that case, as you can see, since they combine together, what we're going to do is simply add. Okay, so that will become P of Z between -1.5 and 0, that is 0.43319, and P between Z between 0 and 1.75, that is your 0.45994. So add both. Okay, add both of them, so that's Z, 0, Z, and 1.75. Okay, that is 0.43319 plus 0.45994, and the total for that is 3, 0, 1, 1, 0, 1, 3, 9, 9. Let's check. Or 4 plus 4, that's 8. Let's check for that one. Okay, we have 0.43319 plus 0.45994. Okay, 0.8 89313. That's the area that covers this part. So this area, it has an area of 0.89913. 89313, sorry. 313. Okay. 89313. Okay. Okay, so the first thing to remember on this one is to take note the illustration. A good illustration will going to make you visualize if you're going to minus or to add. Okay, so another note to remember. Okay, I'm going to write it down here. Okay, so the note that you need also to remember is first, if it is more than if it is more than 50 0 point, if it is more than half of your normal curve, if it is more than half the normal curve, the shaded portion is more than half the normal curve, then add. Okay, this is only applicable for the area to the left and to the right. Okay, if it is less than, or it cannot cover half of the curve or more than half of the curve, less than, more than, okay. Half of the normal curve minus. Again, this is only applicable for the area which indicates to the left and also to the right. Okay, again class, take note of the term at most and at least. When we say at most, we are determining a specific value that it is the most greatest value that it could possibly have. So meaning, all the remaining values are less than that given value if the term at most is given. But when we say at least, that means that the value is the least value that is already given. That only means all the remaining values that we have are more than the given value or greater than the given value. So in that case, when we say at most, it is also saying going to the left. When we say at least, it is also saying that your area is going to the right. Okay, take note of that. And also, when we say between, the between, it depends on if where it is located, where A and B is located. So in this case, for our example number 3, what we have here, for our example number 3, the between. So we could say that in your between, this is your A will be your negative 1.50. Your B will be your 1.75. You could express in that way also. Okay? So whereas you could say that this is A and this is B. Okay. So, but still, in the between part, you need to analyze where is your area is located. So, for example, okay, I'm going to give last example for that. When we say if it is between, example, okay, between 1.5 and 1.75. So, example, okay, between, if Z is between, if Z is between Z C is between Z equals 1.50 and Z is equal 1.75. So as you notice, both are in positive form. So if we will going to draw that on your normal curve, we will going to have that 0. This is your 0. For example, 1, 2, 3, 1, 2, 3. 1.75. This is 1, 2, 3, negative 1, negative 2, negative 3. Okay. So 1.5 is here at the middle of 1 and 2. So this is 1.5. So we could assume for this one, and 1.75 is somehow near your 2. Okay. So in this way, as you can see, okay, if we will going to color that one, this is somehow complicated, right? Okay. Okay, this is the area that you wanted to have. Okay, so for example, we're going to express A as 1.5 and B for more utilized application. Okay, so this is your A, this is your B. Okay, in that case, how would you able to find for the area? Of course, whoever has the greater value, regardless if it is negative or positive. So for example, between A and B, who has the greater value, that is 1.75. Okay, so we will going to make B as your basis to find the area between A and B. How will be able to do that? Okay, because B actually covers, if I will going to utilize your normal curve, the area of B from your what do you call this one? Okay, the area of B from your mean covers also the area of A. So that only means in this case, what we're going to do is simply minus the area of A from the area of B. Okay, so for the area of B, for example, Z is between the mean and 1.75, which is your B. Okay, so that is 1.75. That is your 0.45994. For the area of A, of course, we will going to minus the area of A because, again, class, this area covers only for A and it does not include to your area that is between A and B. So P, probability or area of, okay, we're going to change color for that. Okay. Okay. P of Z between 0 and 1.5, that covers your this is the area which is somehow what we need to eliminate from your area of B. Okay, this is the area that you need to eliminate. So that is 1.5. That is 0.43319. Okay, so in that case, simply minus both area. Okay, minus both area. Okay, so minus we have, okay, we'll go back. P of Z between 1.75 minus P of Z between 1.5. To get the area between is equal to the area between 1.5, which is Z between 1.5 and 1.75. So we will going to have that substitute, okay, substitute 1.75 is 0.45994 minus 0.433319. Okay, and the area between A and B, that is 0.45994 minus 0.43319, that is 0.02675. That is the area between A and B. This is 0. Sorry. This is 0.02675. Okay, so it really depends where is the area is, of course, located. As long as you know how to analyze your illustration, you can really find the area which is already which is what you're looking for.